and welcome to the inaugural issue of Stunt Flier Video Magazine. My name is Bob Hunt, and I'm the editor of SFVM. I've spent the last 17 years editing an internationally distributed model airplane magazine that covered all facets of the model airplane hobby. But like you, my first love is control line stunt, and I wanted to tell the story of this unique sport in a way that would bring out the excitement, fun, and action that it has to offer. While paper magazines fill a need and are still a great medium for communicating information, this is one sport that really needs to be shown in a manner that conveys that excitement, fun, and action. And I feel the best way to do that is with video. Building techniques, finishing systems, flight training, engine reworking, contest coverage, and even personality profiles are all subjects which benefit from live action presentation. There's no way really to capture the same expression with a still camera such as this as you can with a camcorder like this one. Video is the future of information exchange, and that's how we intend to tell the story of stunt flying from now on. Again, welcome aboard, and let's get going.
Okay, this is the Geo XL's father, and I'd like to start with that because that would be the lineage of this airplane. I'm going to lead up to the Geo XL, of which we're going to show you plans and go from there. This aircraft was flown from 1968 to 1984. It was quite successful for me, and this being the USA-1, in case anybody doesn't recognize it. There's another one under the steps, its brother. There were actually 4 built, and these were built with basically, 3 were built with the same airfoils, the same configuration. 1 used a thicker wing. The Geo XL, as time came along, the Geo XL has actually a slightly thicker version, a wing, and a blunter leading edge. They're very, very similar otherwise. We can get into more detail on thrust line and wing alignment as we talk about it. But this is really the heart of what the Geo XL was. In fact, this airplane, if we get decent weather, we're going to be able to show you this airplane flying. It still flies and flies quite well. If it had modern power in it, I think it would be fairly competitive. I would have to say that while I used other airplanes during this time, the Juno and several others, I never really felt like I had any real reason to change other than the fact that, you know, we just get tired of doing the same things every day. This is pretty much the airplane I've flown since 1968, including the Junars. Some difference, I would say that the Geo XL represents near the end of the line for this. I don't have a lot more ideas to put in this particular set of numbers, but I am very happy with the Geo XL. I'll show you both versions today too. There's an inline version that has exactly this wing, and then there would be the inverted engine one that may get used this year at the Nationals that I'm quite happy with. This airplane here started out fundamentally, I wanted to use big airplanes and had been using large airplanes. I wanted a big airplane for Europe, but I didn't feel as though we had the proper power. And that was part of the reason that the wings became thin. This airfoil being only 2 inches at the root. It was a departure from what I had been doing with the Super Aries, which may look similar, but numerically is a completely different airplane. This was the beginning for me of the thin wings. And I'm not sure that some of this didn't come about because of practicing at a field that's extremely turbulent. Now, the airplane actually the original flew very well, and I was able to win the World Championship with it in 1970. This being its brother here, this won in 72 and has been second in the world. It's won the Nationals. It won the Nationals when it was 9 years old, in fact. So they've always taken care of themselves, and I've always felt good flying them. I moved the line along finally with the inline side mount, which I thought was a very good airplane. That we'll show you pictures of. And finally the Geo that I'm flying nowadays, that may appear at this year's Nationals. Other than that, we'll have to go into, I guess, each airplane individually so I could tell you what the changes were and why they were done. This would be the first Geo XL to come out where it appeared with this name. This has an almost exact USA-1 wing. The only difference would be the fact that the airplane is totally in line. Wing, thrust line, stabilizer. This has a larger stabilizer, significantly larger stabilizer and elevator. This airplane I've been quite happy with, still quite flyable. The only thing I would do with it now, it has an OPS and it would be powered by an Aero 50. The main reason I've gotten away from the side mount is there's a lot of problems with headers and manifold, a lot of things that you really don't need in an already complex situation in the front of an airplane. This particular airplane weighs 55 ounces. It's had a rudder change. It was cut down significantly. This plane started its life with twin rudders, and if I were to do it over again, I might consider those twin rudders. I think that the airplane's never flown quite as well with a single rudder. I believe the twin rudder really does give you the feeling of an even larger stabilizer. Just a better feel all over. That's part of why this rudder was cut down in an effort to simulate side area of the twin rudder, and really made almost no difference. It was just a better airplane with the twin rudders. This, as you can see, is the normal pipe setup, and this is a soft mount system in here, which still has value. The next Geo that I'm going to show you would be so far the final Geo. Went back to a regular hard mount and much simpler front end. This is the current Geo XL, built with a Bob Hunt lost foam wing process. The lightest of all. I would consider it the Super USA-1 if there was such a thing. It's an inline airplane, but it went to the basic beam mount just to keep things simple. And this airplane features a 7/8 inch radius leading edge, which was probably the single biggest departure from all the USA-1 configurations. The wing is no thicker. This wing is only 2 1/32 at the root. So it's still a thin wing airplane, but this airplane flies well at low speeds. It's 730 square inches. It weighs about 54 ounces, and which gives you a very good wing loading. It's powered by an Aero 50, which has really brought the airplane totally to life. I may have 1 or 2 more of these left in me to build because I still enjoy this design in this airplane. And it is the latest of the, as I've said, it is the latest of what really started out to be USA-1s. There's your side view. I generally like the appearance of the airplane. This again, I wouldn't mind having a twin rudder version of it. Maybe when it gets older, I may give that a try on here just to see what changes we had. Here's a little view of pipe and pipe tunnel. I feel as though this design is as good as anything that's flying right now. That's why you may see it again soon.
We went along with Bill for a practice session with the GOXL. He flies at a field which is adjacent to Cleveland Airport. The departing jet traffic makes for a dramatic backdrop, and one which makes any airplane lover feel right at home. Bill invited us to come into the center of the circle and get an over-the-shoulder view of what he's seeing as he is flying. Bill, this design series seems to have reached its peak with the GOXL. That series being the very thin wing, large airplane based on the USA-1. Do you see anything in the future, any future improvements for this particular design series?
Well, now that the Aero 50 has brought this size airplane to life for me, I look at the possibilities of flying this design once again on a regular basis. Which would mean that after a year of flying it, possibly I would find more avenues to explore with it. Certainly it's a sound foundation, and I think flies as well as anything that we have around now. And I would be interested in furthering the design.
Recently you've installed a Precision Aero 51 in this model after having flown it extensively with an OS-46 and a Precision Aero 40. What change has this affected in this design?
Well, I've been able to slow the lap times down and retrim further forward lead out positions, a little less tip weight. In general, make the airplane fly a little slower and corner better.
Well, it certainly did that at the field this morning. It was flying at about a 5.50 upright and inverted, and it looked extremely positive in what can be a very treacherous field. So I imagine out on a runway it's going to be even better.
I would hope so.
I would hope so, yeah.
One would hope so.
Well, there are a number of adjustable features on this model airplane. The normal adjustable lead outs and adjustable tip weight. And of course you have removable half wheel pants, so you can change the wheels, so you can use very light wheels in it, and
Right.
Even though they may wear out quickly, you can change them. And removable landing gear systems. But you also are incorporating the adjustable elevator slider to allow you to change the elevator flap ratio. This is on all your airplanes, I see, and can you tell us a little bit about why you find this important and whose system you use?
Well, right now I'm using a slider that Dan Winship makes, and I find it to be the lightest of the top quality. And I use a slider primarily because I've never liked the adjustment from hole to hole. When you're moving things 1/8 of an inch or so, or 3/16 of an inch, you know, the thread is a little bit coarse on the adjustment. So what I like to do is, I like to start very close to 1-to-1. If you build airplanes that weigh 70 ounces, you really don't need this slider. You need 1-to-1 and that's about it. These airplanes fly, most everything I build will fly between 3/4 to 1, the old airplanes, and a 1-to-1 setup. This particular airplane is almost a 1-to-1 right now. But I like that feature. It controls your turn rate sensitivity. It's an adjustment that you can't find with just a handle or a CG change.
Mm-hmm. You've also adjusted turn with the airplane by using different kinds of propellers, 2 blades versus 3 blades. Tell us a little bit about that and what you're currently using on this airplane and why.
Well, I'm using a 11 7/8 4 2-blade. It's a Bali, and I also fly the airplane with the same in a 3-blade. It's actually a 12/4 3-blade, and as you saw, get very similar performance.
Mm-hmm.
I personally like the life in a 2-blade, the ease of turn, but this airplane may fly with a 3-blade this year. It's close enough that I may like the characteristics, the one-speededness of a 3-blade, that I may use a 3-blade with it.
Well, it certainly seems to fly very well in both props, as I've been watching for the last 2 days. That's an amazing airplane. I want to build one very similar to it and put my Genesis aesthetics on it and call it my own.
Yes. Originality is a wonderful
Originality
thing.
is a wonderful thing. This airplane has, as do all your airplanes, just a spectacular finish on it, and yet it's very, very light finish. Can you tell us a little bit about how you go about finishing a model airplane, what products you use?
Yes, I don't recommend, unless you're going to stay almost coat for coat to this system, I don't recommend this. But if you stay within the parameters of this, this is a very good system. I actually start by doping the wood with Aerogloss, thin 50/50, Aerogloss clear. The airplane gets about 3 coats that way, at which time it's covered using the Aerogloss. Then I brush approximately 4 to 5 coats of clear on the whole airplane. Then I spray Aerogloss balsa filler, the white balsa filler, not the sanding sealer.
Mm-hmm.
Sand that. That's a very light spraying. In other words, when I spray this, I don't really spray the whole airplane per se. I spray leading edge, tops of ribs, and I do this. I use a full-size gun, although you can use a touch-up gun is ideal. But I narrow down so there's never really, you really never have that filler laying in between in the rib bays. And the whole airplane you shouldn't pick up more than 1/4 ounce total in filler. Generally, I pick up it's almost not weighable. Okay, at this point, after the sanding, I go to a coat of Sig gray, but I mix
polar gray.
Polar gray,
mm-hmm.
but I mix it with white. Or you can start with white and just put black in naturally and get your gray. As light as I can make that cover in one very light coat, and as light a color as I can possibly make.
And this takes the place of the silver that most people use?
Right. I shy away from the silver. The silver has a way of, people, you know, if you use white, they come out gray unless you put a pint or a quart of color
white on there. Mm-hmm.
I personally don't like to use over a pint of color on the whole airplane. I like to keep it under that, even if it's yellow or whatever. The gray pretty much allows you to do that. And make it, I can't stress enough, don't let it become a dark gray, because then it becomes almost like trying to get it over silver
again. Mm-hmm.
The other thing I don't like about silver is it really has poor adhesion. When people usually pull up tape lines, they generally see the silver.
Mm-hmm.
It works for a lot of people.
But
I think the gray, for my own personal feeling, is a better system.
Well, certainly results speak well for it.
This then becomes all Sig dope. I use some acrylic colors. I lately have been using DuPont 2-part urethane over the airplane. This is one of these new clears.
The high-performance clears?
High-performance clear.
Like a DuPont 380
yeah. I see them working well for other people. I will never use them again. I've had too many little tiny cracks, and I'm not really looking for why this happened. I don't want to make a science project out of paint. I just want the airplane to last. So they will either be SIG clear or the DuPont urethane, or I'll go back to Imron on them.
I believe it was Don McClave that at one point made a comment that your airplanes seem to live in another world than everyone else's because they always seem to look new, even if they're many, many years old. And that's true. I've noticed that myself. Your airplanes never seem to age very much.
Well, it's because I fly so little.
Yeah, right. Well,
I don't know what that's attributable to, other than the fact that you try to get, the Aerogloss gives you really good adhesion on the fillets. Not saying you'll never get a bubble with it, but there's a lot of things that the Aerogloss builds underneath. And they've changed the formula a few times, but I'm still having good results with it. I've gone to nitrates, and I've still found things that I didn't really like. This particular airplane is a nitrate-based airplane with 465 clear over it. So this is a variant on that theme. And this finish really has not held up quite as well as some of the other ones.
But it's still a beautiful airplane. It's certainly light at about 53 ounces on 740 square inches. I can attest to the outstanding performance this airplane displays. I've been watching it now jealously for the last 2 days, and I want to build one just like it, but with maybe a lower fin.
Right, right, as the originality concept creeps in.
Right. Bill, in the past few years, many of the airplanes you've designed and built feature the Warren Truss type of rib arrangement, this angled rib arrangement, which is very torsionally rigid.
Correct.
You did that on the first airplane of this series, I believe, the inline GOXL, and also on your new Thunderbolt. This airplane represents the first time we've combined our forces to generate something new. This airplane was built in the lost foam process with the Warren Truss rib arrangement. Can you tell us a little bit about why you like that and what it's given this airplane?
Well, the main reason I like it, the simplicity of laying it out. I wouldn't say that would be the utmost reason, but the utmost reason being that this wing with controls, flaps, landing gear mount, complete adjustable tips, everything that is ready to put into a fuselage is 8.5 ounces at 740 square inches with very good rigidity and good integrity in shape. That would be the main reason that this is popular with me. My brand new Thunderbolt is built in the same lost foam process, as you know. And in fact, it has something that others have used recently, Ted Fancher. It has a molded leading edge. You know, you made
working
the molds
together on that.
and we worked together on them. This has a conventional leading edge as we were stepping into this process. And this was actually the first Warren Truss version of this, although you had built prototype wings.
Several straight rib wings, sure, but this is the first time we combined our efforts and took your design efforts and used them with our construction techniques, and I think it was very successful, and I think we'll continue to do that for a while.
That's a very, I think we're probably saving the better part of an ounce with this method.
Certainly the angled ribs means you need less ribs in a wing, and of course it adds torsional rigidity, and after the high point where the airfoil is perhaps not so critical, a little bit of fabric seg's not too critical. However, this doesn't seem to have much at all, and that
well,
speaks
we've
well
extended
for
our
the
sheeting
system.
back a little further than usual, and I'm very happy with the whole method.
Of course, being able to generate these rib profiles accurately in any other way, except for an I-beam strip rib arrangement, would be very difficult.
Right.
Well, it certainly has worked well.
And it also gave Bob Hunt a place to finally use foam that we could agree on.
That we could agree on. We certainly want to thank you for having us here at your home and for sharing this with us. This is an airplane I'm sure many of our viewers will want to build, and it's a good starting point if they want to do some thin wing, high area experiments. I think you would probably agree with me that you would want to keep the horsepower up on something this size to get the maximum benefit, and at least an Aero Products 51 or a 40 would be probably a good choice for this airplane.
I agree.
Yeah. Well, thank you very much, Bill.
Okay.
And we'll see you again soon.
Very good. Thank you.
Hi, my name's Dan Winship. I'm in the shop here with Bob Hunt. We're going to go over a few things I'm going to show you. One of the first things I'd like to talk about is a carbon bell crank. And it came about as time went on in search for something lighter, and at the same time make something lighter and then stronger. The weight with the bearings and everything in it, it weighs between 7 and 8 grams. I think normal bell cranks, the ones I've made out of Delrin, run around 14 grams. And show it here as a comparison. This one's out of Delrin, it's machined, and the carbon bell crank is molded. So what I did when I came up with the design criteria on paper, I came up with a master bell crank. And then once I made the master, then the mold was made off of the master. Here's a look at the mold. The mold is it's a female mold, and this mold was made off of the master part. And in order to make the bell crank strong, I really didn't want to drill holes in the part and drill through any of the fiber that was existing in the mold, so I decided to mold the pins into the bell crank. As you can see, these pins retract into the mold, and right before you lay up the part with carbon, the pins come out of the mold like that. You can see better at that angle. So as the carbon is laid into the mold, it's wrapped around the pins. There's a center pin that comes up through the center, and the oil light bushing is keyed from this point here to where it won't come in or out of the carbon. Okay, when one of these bell cranks are going to be laid up, you start with the carbon toe, and I start at the center, and then I'll go around the pin, and when I get to the pin where the next hole is, it's wrapped around. It's hard to show this because it's so loose. Once you wet it with the epoxy, then it sticks and lays in the mold a lot better. So as you can see, the carbon is wrapped around each individual pin. It's wrapped around the center pin here, and each time it goes around one of these pins, it makes a rotation. And there's enough carbon toe here to go around that mold twice. And then once the 2 revolutions around this mold are made with the carbon toe, then I go back with chopped carbon and fill in the voids. The chopped carbon is anywhere from an 1/8 inch long to about 8 microns, I think, which is 8 microns is similar to 8 millionths of a centimeter, I think, if I'm correct. But that'll fill the little voids as you go around the corner and give you a better looking cosmetic part. I don't have any bell cranks when the flashing are still on them. This one, the flashing's cleaned. It's pulled out of the mold, the flashing's taken off of it, and then the brass bushings were inserted after it's molded. And these bushings here are pressed in, and of course the middle bushing, the oil light bushing, is molded into the part. And then to put the lead outs on, it's a brass tubing that's been annealed. I insert that through the bell crank with the cable on it and pinch it over the top, bring it down here, then I swage it. And probably have to cut here for a minute, but I'll get some of the things out and I'll show you how that's done with the annealed brass tube and the swage. The procedure and the step I'm going to show you here can be done on this bell crank or any bell crank for that matter. Whether it's a carbon bell crank or a Delrin or phenolic, or makes no difference. This might not be the ultimate way to do it, but it's just the way I've been doing it. I've got the bell crank, which is carbon with a brass bushing in it at this point here. I've got the lead out cable, and along with the lead out cable I have a crimping ferrule which is made for the cable. The manufacturer that sells the cable also sells the crimping ferrule, and then the tool that crimps comes with it. So all 3 of these components are made by the same place. The reason why the crimping tool is important is because it has the compound action and it collapses the sleeve uniformly around the cable, where pliers will take the cable and it'll flatten it, or take the sleeve and it'll flatten the sleeve instead of. So you take the cable and you put it inside the aluminum tube that's been annealed, not aluminum but brass, I'm sorry, the brass tube that's been annealed. I just used the bell crank as a reference for how much overhang I need. If you go with the AMA rule book, you're going to have to figure that out. If you're going to wrap your lines, you're going to have to measure it your own way to conform to the rule book. The cable and the annealed brass tube are inserted into the bell crank. And then from there I just center the brass tube and I pull it over on itself. Now it seems at this point that the thing will never be free again, because right now it's tight and it's not moving. Well, if the tube has been annealed properly, you won't have any problem. You just bring it down over on itself, and I pinch it a little bit past what it should be, and I'll work it back and forth. It'll start to move, and I'll even pinch it some more and twist it and align it. And then from that point, I'll open it up just a little bit. As you can see, it starts to move real free. Now the rule of thumb, if the lead out will hang by its own weight and swing, that's usually adequate. You might work it back and forth a little bit, put a little oil on it. And another thing that might be worthwhile is to pull test that. Put the post in the vise, rig it up some way where you could pull test 40 or 50 pounds or whatever it would take that you're flying your plane on, and then see how these fittings react to the pull test and see if they collapse anymore. But as you can see, that's pretty tight right there, and there's really not much room for that to collapse any farther. The furl is inserted on the cable, and it's brought up over the cable. You got to keep the ends of these cables together. Okay. See where the furl is inserted up on the cable. This isn't a Nika press tool, but it's the same thing. It's a different brand name. The oval sleeve is inserted into the tool with the cable protruding through it. And when you squeeze it down, it'll collapse that furl around the cable. And the manufacturer sells the swage tool, the furl, and the cable. Guarantee that that furl will withstand the breaking strength of the cable, which in this cable, it's 185 pounds. Okay, what we've done here, we've made a loop of this cable. This is 185 pound breaking strength. And we've swaged each end with a loop, similar to what you'd have on your bell crank. And what I'm going to do is demonstrate how this breaks and where it will break. And you'll notice that these sleeves will hold the cable without the cable slipping through the sleeve. So the cable almost will always break down in here somewhere. I'll close my eyes, but probably be wise if you wear goggles to do this. So I'll just pull up till it breaks. And you can see, you still have the loop. And I don't know if you can get a close enough shot, but both pieces of cable are still down in there. So what had happened, this stayed intact, and there's a stress point right here at the end where it finally broke. But the key point is the cable broke, and the cable broke without it sliding out of the furl. So, and that's what you want. It's like a glue joint. If you make a glue joint and the wood tears apart and the joint doesn't fail, then it's a successful glue joint. So that'd be a successful termination if it withstood the cable. So.
Hi, I'm John Brodak. Welcome to Brodak's Hobby Shop. We have a full line hobby shop. We handle everything from trains to boats to cars, radio control line products. We also rent videos, but we specialize in control line products. Now I want to introduce you to our staff. Patty, you talked to her many times on the phone, most of you our customers.
Hi, I'm Patty. I'm one of the people you talk to on the phone when you call and place your orders. I would just like to say that most of our customers are so nice on the phone. They're not what you would expect. We do a lot of control line business, and I really like it.
Now introduce you to Linda.
Hi, I'm Linda, and I talked to you on the phone also, and I'm waiting to take your call.
Well, thank you very much, John. It's a pleasure to be here today. This is a very interesting hobby shop, certainly one of the largest and most well-stocked I've ever seen. Would you give us a tour of it?
I'd be happy to. Okay, we can start over on this aisle. This is where we have our canopies, see bent landing gears, a lot of cows, instrument canopies. We also carry our mufflers over here for Fox engines and OS and Super Tiger.
What do we have on this wall over here, John?
Well, we have a full line of X-Acto products, Dremel, K&S, sanding belts, just about anything you need, we have.
That's a very impressive stock.
Thank you. We try to keep up with all the newest items out on the market. There's so many of them, as you know. Well, this aisle you can see quite a selection of props. We have about 5 different brands of props. Of course, starters, rubber bands. Here we have our spinner hubs, full line of that, and we have 5 different manufacturers' spinners. We handle 3 or 4 brands of glow plugs, pumps, electric starters. In the full line, we have 5 different manufacturers of wheels.
Including the old Perfect series
The
that
old
you're now handling now, right?
Yes, yes.
Okay, would you explain some of the things in this aisle, John? I see an awful lot of control line products in this aisle.
Yes, we have 4 different brands of fuel tanks. They seem to be hard to keep up with, so we handle different companies. And we also purchased the rights to do the Perfect tanks, so now we're manufacturing all the Perfect tanks. Now you're coming on to full line of motor mounts, of course all different fuel lines and all the filters and all the different accessories.
Okay, John, on this side of the aisle we have what seems to be a mecca for model airplane engine builders and rebuilders.
Yeah, we try to carry a wide variety of all parts for engines. You can see a full line of Cox parts and OS, and of course Fox. We have just about all the parts that you would need to repair a Fox engine.
Including all the gasket sets? And
yeah. Yes.
That's really impressive. Well, at the end of this aisle we're in now is one of the most impressive things for control line flyers.
Yeah,
a hobby shop that caters specifically to our needs and has a full range of the items we use in our modeling, including handles of many different types and makes, including old Easy Just hot rock handles and Easy Just handles. And what do we have on top there? Is that a Sullivan brand handle?
Yeah, Sullivan, yeah.
And you have your own line of fully adjustable handles. And we have bell cranks. And you were also handling now and remanufacturing the old J. Roberts line of three-line systems.
Yes.
Including the handle and the bell crank.
The handle and the bell cranks, yes.
And of course, for control line flying, an essential part of it is control lines, and John has a full range of makes, brands, and types of control lines, including his own. And for you collectors, John has a large stock of older type lines, including Hyde Johnson core cable lines, as we see right here. Collectors should definitely call John and ask about the many and varied old items he has out in the hobby shop for sale right on the shelves. Here's something we haven't seen in a long time. Pylon brand lines on the old cardboard reels. You have an extensive array of accessory items, including Klett brand, Carl Goldberg, and Dubro, full line of Dubro products, accessories, screws, nuts, bolts, brackets. And John also produces his own line of hardware. It's a full hardware line, including all the nuts and bolts and grommets and screws, lead-out wire, landing gear blocks, lead-out guide sliders. Again, a full range hobby shop. You have a very extensive display here of model airplane engines. How about giving us a look at it, John?
Okay, we have 5 showcases of engines, starting here with the Cox engines. Of course, we handle every size that they make. In over here, OS, and same thing there. We handle the full line of all OS engines. But the engine that we really try to sell, because it's American made, is Fox engines. We have 3 cases of Fox engines, every size that they make. And we do have some odd engines too, like K&B. We have some K&Bs and ASP and some Irvine, but very little of that line. Mostly we try to cater to the Fox engines. And here you have some of the older Fox engines, the 35s and stuff, not the anniversary, so we even have some of the old engines.
Again, collector's items on display and for sale, right in Brodak's Hobbies. What do we have down this aisle, John?
Well, this is a full line of all different kind of paints and dopes. We just took on the perfect line of paints, which is fine line. They have a full range of military colors. And of course we have the regular covering, Black Baron and Monaco. And then down here's the dopes, SIG dopes.
That's the largest selection of SIG dope I've ever seen in a hobby shop, John.
And we carry the full line of striping tape too.
Now, John, on the other side of this aisle is, I think, what we're all waiting to see.
Yes, my favorite part of the store.
Do you want to tell us about it a little bit?
Okay, this is a full line of control line kits. Now we know that Sterling been sold out, so I don't know if they're ever going to come back with some of the kits they have, but right now we still have quite a few on stock.
Ah, collectors take note. These are original box, original Sterling kits for the Mustang, the Yak 9, and the later version Ringmaster. Let's move up a bit, John. What do we have up here?
Well, these are reproduction kits here, but we've got this Profile Stuka and the Warrior. I only have a few of them left. They were made out of Florida, and they since then went out of business too. But here's our line of carrier planes, our 3, Bearcat and Sky Raider and Corsair. And we still have some control line classic planes left, the Viking and Buster, Super Powwow. Believe it or not, we still have an Aries left.
Ah, Bill Werwich, take note.
And we carry a full line of SIG control line airplanes.
Yeah, the Twister, the Banshee. And here we see your line of control line half-A kits.
Yes. Mm-hmm.
These are all manufactured right here in town. Carmichael's, Pennsylvania. Collectors, take note. Right on display in the store and for sale, early Piper Cub kits from Sterling Models. This is the only hobby shop I know of where you can go and find collector items on sale every day, right on the shelves. Well, John, you must be pretty proud of what you've accomplished here, and you have right to be.
It's been a pleasure, especially in the control line part of it. I really enjoy it.
Well, we certainly appreciate what you've done for this hobby. John, I'd like to move along now and go see some of the manufacturing facility. Can we do that?
Okay, yeah, we'll go next door.
I know you want to get changed so you don't get your clothes dirty here, so let's go do that and take a trip over to the manufacturing facility.
Okay.
On our way to the manufacturing facility, we got a bit sidetracked. We're going to take a look now at John's personal building room. There he is. Hi, John. Tell us a little bit about your building room here.
Okay, this is where I build all the kits before I kit them. And I check easy ways to build them like we do with our leveling bar in the back of the wing. We experiment with different things, so once you buy the kit, it's easy to build. Now this is the Oriental that I just finished up, and we'll be coming out with this part in about 30 days. I know we promised it a year ago, but we got sidetracked with the half-A's. But now I have it done, and books written on it, waiting for the labels to come in, and then we'll go ahead and kit this. Over here, we're thinking about coming out with the Warbird series, a series of about 10 airplanes from the Second World War. Right now, what I'm doing is setting this up to see what's the best way to build the wing, putting these spacers in here, because we've got to raise this 1/8 of an inch. So that means we got to follow it down, so when you lay your middle spar and a leveling bar on, it'll build you a straight wing.
Has a proper degree of airfoil taper.
Yes. And that's so difficult for somebody to do without having some kind of jigs.
So everything that you produce, you first build and make sure that it can be built accurately and quickly by the average person.
Yes.
That's a good idea. This is a very nice shop. It's well lit, and it's complete with all the power equipment needed to do a good job. Certainly a lot of modelers out there are going to be jealous looking at this shop.
I spent so much time in here, so I made sure that I had it nice and comfortable, air conditioned, we're all lit.
What's through this door over here, John?
Okay, and here where we paint the planes. I still paint everything with dope. I know there's a lot of different processes. You can make them lighter, as I've been told, which I'm going to try. But okay, right here now, I see the Tiger Cat's coming out within the next 30 days too. So this one I've painted all black. This is the model I'm going to be flying. And this right here is the Profile Oriental. I already got the primer on it. I'm getting ready to color it. So all three of these kits should be out in the next 30 days.
So this is actually a spray booth you have in here.
Yeah, well ventilated. Got a fan here. Got filters. I close the door to filter the air across. And I still wipe all the walls down because when you prime something, you know it just goes everywhere. So I try to keep it as clean as I can.
And this entire building is separate from your house.
Yes.
This is in the back of your two-car garage at your home. And so you don't get any fumes into the house. And,
right.
And make Buzz, your wife...
right. They catch on to that right away when you paint.
Make her sick from the fumes, right. Well, you have a selection of paints here and thinners. That's very interesting. What a builder's paradise. Hey modelers, if you're really ready to be jealous now, this is John's backyard. There's room enough on this field for 4 circles. And the main circle they fly off of is over by that tree line. It's got a concrete runway. shaded areas to sit. This is really wonderful. And you even have a windsock mounted high enough to see what the wind is doing near the 45-degree elevation point. I want John to adopt me. We're now looking from the end of the circular driveway in front of John's very much plantation-like house here in Carmichaels, Pennsylvania. Reminds you very much of a house you might see in the Deep South. This is absolutely a gorgeous place to live and work. Lives here with his wife Buzz. The garage you see is in front of his workshop. His workshop is in the back of this garage, two-car garage, as well as a spray booth separated from the house. Keep all the fumes out of the house. And the flying field is behind that. This is how every control line modeler should live.
And now I want to show you where we manufacture our model airplanes. It all starts in this room right here, our design room. And I'm going to introduce you to Dave Brom. Dave is the one that designs most of our kits. He does most all the drawings. He's pretty professional at it.
Hello. Welcome to our little corner of the world here. We're just in the process of revising some of the Super Clown old-time stunt airplane, updating bell crank systems and hinges on it and tank straps. This seems to be a fairly popular kit. We've got another Flying Clown series coming out with it to go along with it. So we have all three, a half A, a 15 size, and a 35 size.
And over here, we do our instruction book. We like to put a real detailed instruction book in with all of our kits. We take over 200 pictures to do one book. And then we go through and rebuild the whole kit through the pictures. And we also have our labels designed, full color. We do all the printing in-house except for our labels and our decals. Our decals and labels are printed outside. And we go over the kits, over the instructions many times. We always seem to find some little mistake, but we try to correct everything, try to make it as near perfect as possible. In here's where we make our plans on this machine, the Xerox machine. We can make up the 52-inch wide plans. And it might seem like a slow process, but we can do 100 sheets an hour. Next, I'd like to show you where we make our parts for our model airplanes. First of all, we make a very accurate template of our fuselage. Now what we do is we pin route it out on this pin router. We have the pin sticking up that rides on the outline of the fuselage. With the cutter comes down and it cuts it out. We place a piece of 1/2-inch balsa wood, 4-inch wide, on our jig, clamp it down, and we set the jig right over the pin. Now this pin guides it around as the cutter cuts it out. As you can see, we got a very accurate duplicate of our fuselage side. Now this process takes us about 2 minutes for each fuselage. Next we're going to show you where we shape our leading and trailing edges for our half A's. So I'm going to let Dave take over now. Dave, you want to show the process?
All right, we've had a special cutter designed for the mill, for the shaper, that will cut 2 leading edges and 2 trailing edges all at the same time, so that they're all accurate. So I'll show you one going through the machine here. As you can see, that's a real accurate way of cutting all 4 pieces at the same time. And they're just a small, thin piece of strip holding them all together so you can put it all in the same kit. Okay, then we'll show you how we cut the notches for the ribs in it.
Okay, next process is we cut these to the size that we need, which is this right here. Now to get our notches exactly right on here, so when you snap these apart and put them on the plans, they line up correctly, we go to this machine here. Yep, okay. We have this jig made where we line the first piece up to make our first cut. From then on, we follow through by putting this notch. It keeps us exact alignment. Now this notch goes over and clamps there. Then we just take each one over, put it in place. Now as you notice, the notches are all lined up perfect. And when you get this in a kit, all you do is snap this apart. You put this on a leading edge, line it up on the plans, and it'll come out perfectly. Now we want to show you our die cutting process. First, we have to make a layout sheet with all the parts on it that we want die cut. As you can see here, it's our ribs and our rib tip ends. We send this in, and we have dies made. These dies are made in New Jersey for us. You can see the back of it, where they place the steel. And the rubber on here is for when the part cuts out, the rubber pushes it away, so it don't stick between. Now this die goes into chase, into the machine right here. We put the balsa wood in this part of it. Oops, you can see our die cut parts are pretty good. And of course, this comes together and a die cuts the parts out. And you can see we try to do a real good job in die cutting. You can see these pieces just fall right out. Now this is the room where we store all of our balsa wood. And it's also the room where we package the kits and shrink wrap them. What we do is we lay out enough parts to do 20 kits. And we got this laid out for the baby lightning streak. As we go through and package these kits, when we end up at the end, the last kit, we should have left on the table one of each that goes in the kit. And if we find that we have a part too much or not enough parts, then we go back through the kits and find out where the mistake was. That way we can pretty much assure that anytime you buy one of our kits, you're going to have all the parts needed to finish the airplane. This is the machine that applies our shrink wrap to the kit boxes. That's the finished product.
All right, here on my right you'll see a stack of lightning streak kits completely shrink wrapped and stacked in inventory ready for shipment.
Brodak Manufacturing is a company which specializes in control line model airplanes. They also sell many ancillary items which are used in control line flying. Among these are control line sets which must be spooled on plastic reels. This is the room in which this procedure takes place. Dave Braun is going to show us how the line sets are spooled onto the reels.
We've got a special mandrel here. We'll put the plastic reel on it, attach the lines to it, and wind on the required amount of line, whether it's 52 feet, 60, 70 feet. And this completed item is put in a package with all the connectors and eyelets to make up a complete line set.
The plastic reels on which the control lines are spooled are molded in two pieces. They must be glued together prior to spooling these lines on. One side of the reel is dipped onto a rag which is wetted with solvent, and this softens the plastic. They are then assembled and put into this rotary table fixture and clamped. Then it's rotated to the next station and the process is repeated. When all of the reels on this rotary table have been treated, the last reel that comes off is dry and ready to have the lines spooled on them. Here's a box of completed reels. Proper line care is a very important part of control line flying. It's best to always store your lines on as large a reel as possible. Recently, John has obtained the rights to the 5-inch pylon line reels, and he's now making them available to us at a very reasonable price. This is the handle manufactured by Brodak Distributing. You notice that it is adjustable in overhang, in line spacing, and it's also in-flight adjustable for sensitivity to neutral. You can reshape the handle portion to suit your grip, and you can finish it to suit yourself. Here are 3 new control system components from Brodak Manufacturing: a 4-inch nylon bell crank, a 3-inch nylon bell crank, and an adjustable lead-out guide fixture. The bell cranks feature offsets to make pushrod installation easier. They also feature a molded nylon bearing. The adjustable lead-out fixture is made from plywood and has a Delrin slider. Brodak products are available at better hobby shops everywhere. If your local hobby retailer doesn't carry Brodak products, suggest to him that he should. If you don't have a hobby retailer near your home, you can order direct from Brodak anywhere in the United States or abroad. Brodak has a complete and well-illustrated catalog of the products which they produce, as well as products from other manufacturers which they distribute. The Brodak catalog is priced at $3 and is well worth the price because it is also a great general information guide to control line flying. The catalog contains articles on beginning control line trimming and flying techniques, instructions for learning how to perform aerobatic maneuvers, control system layout drawings, diagrams of the various types of competition patterns that can be flown, introductions to control line combat flying and control line racing, an article on getting started in control line carrier flying, and an article by John Thompson on building accurate control line model airplanes. The catalog also contains a detailed, illustrated listing of the kits which are available from Brodak. These include profile sport aerobatic designs, an extensive line of half-A models, classic designs from control lines past, and kits manufactured by other companies. The Brodak catalog has a complete listing of finishing materials, tools, and accessories. It is an indispensable modeling reference source.
This is Ted Fancher again. I'm standing there with Scott Metzner, I believe. Scott, where are you from?
I'm from Albuquerque, New Mexico.
Is this your first vintage stunt meet?
Yeah, I just attended it just to watch all the flyers and all the neat planes out.
Uh-huh. Do you have a favorite airplane here yet?
Probably a Nobler. I like
Probably
those.
the Nobler, yeah. I noticed you've got a beautiful airplane. Is this yours?
Yeah, it's mine. Me and my dad and Jack Bryan built it.
What's your dad's name?
My dad's name is Pete Metzner.
Pete Metzner.
Mm-hmm.
Okay. And tell us what kind of airplane it is, what engine you've got, and the weight and so forth. Just some of the details of it.
Well, it's a Buccaneer 740, about 49 ounces. It's got a OS 40 FP right out of the box, and it runs great.
Runs great, huh?
Yeah.
How many flights on it?
I'd say about 30 maybe. We haven't got it trimmed out quite yet.
Right. This is an Allen Brickhouse design, right?
Mm-hmm.
Is it built from a kit?
Yeah, straight from the kit. Good wood.
Good
Foam.
wood?
Yeah, real good wood.
And it went together well, obviously.
Yeah.
What kind of finish, Scott?
Sig dope, 380S clear.
Has it been rubbed out yet?
It has been.
Yeah, it's just absolutely gorgeous. I'm very impressed with the weight of it.
Oh.
Tell us a little bit about yourself. How much do you fly? Are you a competitive flyer yet?
Well, I'm an intermediate flyer. Flew in the Nationals 2 years ago. Got second place in beginner. I've been competing in local events around here.
So you're flying the entire pattern with this airplane?
Mm-hmm. Entire pattern. Yeah.
Terrific. Well, it's an absolutely beautiful model. We're glad you come out. Are you going to build an old timer for next year and come out?
Yeah, I'd love to.
Yeah, we'd love to have you here.
Hi there, and welcome to the first installment of Engine Basics. My name is Dean Pappas, and we here at Stunt Flier Video Magazine will be bringing you a continuing series of articles aimed at satisfying the other 75% of stunt, which is to say, getting a good engine run. The importance of this cannot be stressed too highly, as everything from airplane trimming to simply keeping your airplane in one piece are contingent on this. And nowhere is help for the beginner so badly needed. In this column, we will be talking about engine selection, engine modifications, tank construction, installations in the model, and finally, field applications. we would like to start out by discussing engine selection and, well, first by giving you tools to help you select engines for control line stunt. It's a well-known fact that the vast majority of engines made are in fact made for the much larger mass market in radio control. And rather than bemoan the fact, we here are going to explain to you how to select an engine based on its parameters, its exhaust timing, blowdown timing, crankshaft timing, and the design of the flow inside the engine. And if necessary, make modifications to that engine so that it is suitable for our purposes. Before going on to the more important matter of selecting engines, what we first need to do is develop the tools in order to be able to characterize them. The most important thing we are going to do is measure the timing of an engine, and eventually we're going to be modifying the timing of those engines. If you look in the package you received with your issue of Stunt Flier Video Magazine, you will find an official Stunt Flier Video Magazine timing wheel. Lovely, isn't it? I didn't have to iron mine flat. You will have to do that to yours because after all it was wrapped around a square little box. What we're going to do is we're going to glue this to a sheet of cardboard or plywood and then build a timing wheel and start measuring an engine. In future installments, what we're going to do is talk about what kind of numbers characterize a stunt motor. And after that, we will talk about what kind of effect varying those timing numbers have. And then finally, we're actually going to get down to cutting metal. And this is the stage where a steady hand, that means no more coffee, and a Dremel tool, and a couple of wasted engine parts until you get it right. But you will learn how to eventually modify your own engines for use in stunt. Certainly, there are a great many finely made motors out there that don't require any modification at all. But even so, an understanding of just why those numbers are what they are will be very, very helpful. And as I said, most of those engines you will be modifying from RC use. Well, they say that a workman is judged by his tools, and we're about to build our own. Sort of thing a modeler can do, right? I've taken the timing wheel diagram that you got in the package with your tape and carefully cut it out with a pair of scissors. I did that off camera because I'm slow with the scissors. I have a piece of plywood and some contact cement, in this case some 3M77, a coat hanger to make a pointer. I like to use coat hanger wire because it's easily bent and yet it's stiff enough that it doesn't move out of the way when you're working. And on the back of this engine here I have a screw and a pair of washers which you could use to either bolt the timing indicator to the mounting lug, you'll notice this engine has none, we'll talk about that in a minute, or to one of the back plate holes. I've also got a collection of tools here for mangling the wire, diagonal cutters and a pair of round nose pliers. And let's start. First, a little contact cement on the timing wheel here. And while that dries, we get to talk a little bit. Usually what you'll do is you'll make up a timing pointer out of coat hanger here and bolt it to the mounting lug on the engine. So that will require a screw and a pair of washers and a nut. And we'll make a little arm that reaches out this way. This engine, as you'll notice, has no mounting ears. And the reason for that is probably one of the most important criteria for selecting a stunt engine, and I think it bears discussing now. That is weight. Weight is critical, and extreme lightness, both in building our airframes and in terms of putting our power plant packages together, are one of the things that separate stunt flyers from the rest of modeldom, if not from the rest of the world. It's something we're all quite proud of. This engine was used in an airplane mounted by a thin plate on the back to a soft mount. And in order to take just the last little bit of weight out of the airplane, we cut the mounting lugs off of it. This started life as a Weber 32 and with very, very few modifications makes an excellent stunt engine. And as a matter of fact, a Weber 32 later on will probably be our prime example when we start cutting into the engine timing. Well, this stuff is dry here by now, so let's get to it. This is hardly an issue that any modeler needs a discussion of, but it gave us a chance to talk in the meanwhile. And next, of course, let's cut this thing out. If it isn't sanded properly, let's face it, it isn't a modeler's job, right? Positively lovely, isn't it? Now, next thing to do is to drill a hole in it. And you'll notice that there are a pair of marks for either a 1/4 inch or 5/16 inch hole. And a little bit of trimming with the knife. And there we have it, one official Stunt Flyers video magazine timing wheel. Well, now let's use it. Next, we make ourselves a pointer. And as I said, coat hanger wire is my favorite material for this. And we have lots of these pieces of cut up coat hanger lying around. Bend a little loop in the end. If you don't have a set of round-jawed pliers, this is not the most critical task you'll be doing with it. Go get yourself a set of round-jawed pliers. Lead outs, any one of a number of things in the control system where you need to bend a piece of wire and make sure that you don't have any stress fractures, make sure you got a set of these, okay? And in our case, as we discussed before, I'm going to bolt this to the back of the engine. And the timing wheel to the front of the engine. Well, we mount the timing wheel, and you'll notice that I've put the indicator on the left side of the engine. This is just something I do as a matter of course. And I have rather carefully taken the motor, put it somewhere near bottom dead center, that is with the piston down, and through the glow plug hole I'm going to take a round-ended wrench. If you feel more comfortable using a wooden dowel or something that won't scratch anything, I recommend you do so, and just gently push down straight. This places the motor very, very close to perfect bottom dead center, just as a matter of course. I like to take the bottom dead center mark, that's the 0 on the inner ring, and I like to put it on the same side as the indicator, because final adjustment we'll do by bending the wire, but just for an initial setup, I like to put it here on the same side. And tighten the nut. Had that lurking off camera, wasn't that good? All right, that's on snugly, it won't move. And now it's time to set the timing indicator to get everything right. First, let's just get everybody roughly aligned. Once again, push the motor to bottom dead center. And bend the arrow. Let's trim a little of the excess off here. And I like to make the wiper actually rub a little bit on the wheel, because that way a little bit of drag keeps me from losing my setting. The first thing we're going to do is verify whether this arrow is in the right spot. And in order to do that, we have to make a rough measurement of the exhaust timing. All right, what we need to do this, let me first clear the area out here. What we need for this is a small pen light type flashlight. What I like to do is to shine a light in the glow plug hole. You'll notice from the beginning that we haven't had a glow plug in there. And shining a small light into it, look into the exhaust port. Now you won't be able to see this in the camera right now, but we'll do this again later so that you can. And you can tell the very beginning of the opening of the exhaust port by looking in the port carefully and starting with the piston port closed off, just slowly back it out until you see the light come out the slot. If you have good eyes and a well-lit shop like this place is right now, you don't even need the flashlight in the glow plug hole. And in just a moment, what we're going to do is we're going to dim the lights and demonstrate that to you. I'll start here though by first setting the indicating pointer. I have turned the engine from bottom dead center. There's bottom dead center again, basically. I have turned it to the before bottom dead center side until the port is just closed. I can see the barest hairline of light coming out of the exhaust port. And when I read the meter, I see 10, 20, 30, 40, 50, 60, 70, 77 degrees before bottom dead center. I'll do the same thing for the after bottom dead center side. And I read 67 degrees after bottom dead center. Well, needless to say, I'm off by half of the difference between the two, or about 5 degrees. So I'm going to move the lever 5 degrees and then do this again. And that should read there's 63 degrees. And I overdid it. And of course, if it takes a little while to get this nailed correctly, that's okay. And before 72 degrees before bottom dead center, and for the other side, 72 degrees before bottom dead center. Well, it took me a few minutes of fiddling around here, going back and forth between closing the port on the before and closing the port on the just after side, until I got the needle bent to where the reading was the same on both sides. Let me turn the light off here and explain just what I mean by that. With the engine at bottom dead center, that's right here, and you'll notice that corresponds to, that was top dead center. Pushing the engine to bottom dead center, the timing mark is at, or very close to, 180 degrees right there. And 180 degrees away from top dead center. The outer ring is top dead center. And the inner ring here is marked from bottom dead center. It's just because it's the easiest thing to pick off. With the engine set at 0 degrees from bottom dead center here, the distance in degrees to the closing of the exhaust and intake bypass ports, those are the ports cut in the cylinder wall, will be the same number of degrees either side. That's inherent in the construction of a two-cycle engine.